So Act 2 is getting information. So that was the part where I was like, okay, we decided that on Monday, we decided how many pennies, we want to know how many pennies are in the pyramid. What do we need to know to answer that question? So today we're saying we want to know what Dan's indoor split time should be. Aside from just giving you the answer, what information do you think you would need to get there on your own? We know that on an outdoor track, his split time is 1 minute 15 seconds. We want him to be running at the same speed. On a smaller track indoors, what should his split time be? I will ask students to have some think time, some writing time. Then I'll ask them to share their ideas with each other. And then we'll come back as a class and I'll ask, tell me some stuff, and I'll scribe what they tell me. So why don't I give you a little bit of think time? Maybe turn to a neighbor. What information would you want and why? Wasn't a very satisfying melody. You liked it? Okay. It didn't resolve how I wanted it to, but that's all right. Okay, sorry. So I heard a lot of good discussion, both about the information and just about this process in general. So I'm glad that you had some time to do that. Did anyone need to see the video again? Yeah, why not? It's 30 seconds. Let's just watch it again. 31 seconds. And it's right here.
So sometimes when my students are doing this questioning process, I just run the video on loop without
Nice.
noise so that they can have discussion and still use
I'll usually have, I'll always have at least like a frozen frame of the video. Like this is a particularly good frozen frame of the video. It reminds us of the 1 minute 15 second split time and the sizes of the tracks. I'll run it one more time. And I usually almost always I run the video twice before we even start, just because I feel like middle school students benefit from that. Yeah.
Can you get captions on there? Is that an option?
Closed captioning? Yeah. That would be awesome. This is a file that Dan created that doesn't have closed captioning. If you can find Dan's video on YouTube, you might be able to turn captioning on. That's a good point. All right, that was the video. The question was, what should that indoor split time be if Dan's going to run the same speed on both tracks? And I heard a lot of this same information being discussed. Yeah, split time is 1 lap. That's some good vocabulary to define. So length of both tracks I heard overwhelmingly as I eavesdropped on different tables. Some people were restricting themselves further. Like, if he gave me just this right amount, I could find the length of both tracks. It's like, no, I'll just give it to you, because the focus is proportional reasoning right now. Students might not know that, but that might not necessarily be clear to students that that's the focus, and that's okay. So I would happily give you the lengths of those tracks. The outdoor track is a 400-meter distance. The indoor track is a 160-meter distance. This is the part where I remind students that since they asked for this information, I assume that they had some sort of a fuzzy plan of what to do with that information. And then I'm going to send them off to try something. And that can be as collaborative as you want it to be. If you want this to be some sort of a formative assessment, you might say, okay, I gave you everything you need. Work individually and silently. Or you might say, go for it. Talk with people at your table. Help each other out. Let's see if we can find Dan's indoor split time. If you haven't started doing the math yet, why don't I give you a couple minutes to do the math? Then we'll look at what students did with the math.
So, Steven,
Yes.
how in Act 1 you talk about the environment? So, if you're outside, you're going to have wind speed.
What happens when students bring that stuff up?
Right, that would probably be in Act 1.
That would be in Act 1 that students would bring that up, and that would be a great opportunity to talk to your students about mathematical modeling. Like, because every year, students bring stuff like wind speed and incline up, and I go, and it's always a boy, and I'm like, look, dude, right? The more complex your mathematical model is, the more close to reality it'll probably be. Reality's super messy, and you're 12 or whatever. So you need a model that's simple enough that you can work with it, that does a pretty good job of simulating what happens in the real world. So if I gave you wind speed, what would you do with it? And they're like, I don't know. Like, exactly. So, I mean, sometimes I'll draw, at some point in the year we'll do like a continuum of like a mathematical model. We'll do like simple to complex. We'll do like solvable to unsolvable. So it's like somewhere in the middle, you decide what parameters you're going to use from simple to complex, and that relates to the math that you're going to do. And it's either going to be solvable or unsolvable. Yeah. And they always want it in this problem, like wind speed, humidity. I'm like, what are you going to do with that? I don't know what to do with that. Yeah.
Are we doing it
I think at any point we could just leave this up, and we could just plant like.
Between pairs.
Yeah, just go in there and heavy hand it. Like, here, you two talk. What would you do if this was the work you got from 2 or 3 different students? Up to you. I see people still working, so maybe give them more work then. Let's play it by ear. Let's do it. Let's give it to people who are done.
Okay.
That's an idea.
Well, that's the answer right there. I mean, you got
Correctly. And you're really good. I will begin one word and end it with the end of the second word. No, I use white.
No, I got like 5 minutes.
I use whiteboard pens on the overhead because vis-a-vis are you end up with color all over your hand when you can't erase it. And then your little wheelie thing, the film gets
I'm ready.
Okay, oh, this is some student work here.
It is indeed. So these are 3 different students who explained to me how they solved, and I scribed on the smartboard.
2.5.
And this is 2 different students. I scribed on the.
This is your ratio. This is not the ratio.
Look at it. This would be a particularly good compare contrast. How different is the thinking behind these methods? Is it accurate?
This is exactly the same thing.
This is student work from this problem, yeah. So, if 2 different students gave you these solutions, what does it tell you about those students? I'll also say I do this I do this before I do any teaching in my proportional reasoning unit, because I teach 7th grade. They all have some experience from 6th grade, and so this is my sort of pre-test, I guess, at like what skill levels in the room with proportional reasoning with rates.
Question.
Yeah.
Are all of the instructors here still classroom teachers? Thanks.
Yep. We're just like you.
I'm glad I communicated my thoughts. And not one of these kids did it my way.
Nice.
Even looking at you. I do it my way either.
I'll also point out, when I do this lesson with 7th graders, I do it before I do any teaching about proportions or ratios or rates. Huh?
I didn't use proportion.
Nice. Neither did any of them.
Yes, they did.
Well,
That's a proportion, that's a proportion, and that's a proportion. It's just written differently.
oh, interesting. But it's not like this over this equals that over that.
But it is. This is just
But I mean, it's
400 over 160 equals 75 over x.
right. You're right. But when you teach students that you can do number over number equals x over number, they just know that there's 3 numbers in the problem, and they need to go into that. I mean, if you look at the picture,
Right.
it's a friggin' proportion. Like the one that's not labeled as x, but like, which is hilarious to me.
This guy did that, but
Oh.
converted it all to minutes.
Yeah, nice. Yeah, but so I do this before I do any teaching, because they've all done proportion stuff in proportional reasoning in 6th grade. So this is my way of getting the finger on the pulse of who knows what.
I'm impressed with this one. You know, hey, let's do it all in minutes. Let's convert.
Almost no one does that.
Yeah.
That's like 1 out of 100 kids did that. The minutes.
Whereas I just converted to miles.
Why?
Because a split time of 1:15 means it's running a 5-minute mile.
Because 4 laps.
160 meters.
But you
I
have to
need-
know that 4 laps is a mile to do that.
Right. But 160 meters is you need 10 laps to do a mile. 10 laps, 5 minutes. Each lap is 30 seconds.
Nice. Sweet.
See?
How many indoor laps is a mile?
10.
That's how we got to the
Because 4 times 400 is 60.
The setup, I'm okay with the setup.
I wanted to find out how many of these were here.
You're okay with the setup?
Really hard.
Yeah.
Yeah.
And then
Worked really hard.
Could they have worked less hard?
divided the 75 minutes.
It's a different way to think about it.
Yeah.
I was just saying because they're two different quantities to me, I wouldn't think to simplify it to a decimal.
Divided by 1 1/4.
But what if you had a calculator
15 seconds is a
and it was as simple as pressing the buttons?
I still want it because the work I have to show.
So what if I told you that this student had a calculator and this student didn't?
But we were just talking about this before. We don't know if this process is because this person wanted to simplify this ratio, or is because they saw 160 coming and that's why it's trying to get the big
How many of the songs?
Why didn't they change it to a rate?
Where did that
Oh,
25
and that's why
come
that person didn't do it. If they had a calculator and they didn't, that's why they didn't do a unit rate. I still think this is a more complex process because of this.
No, I
Variable.
yeah.
You have to know how to do that.
Totally. So how does that connect to cross multiplying?
Divide by 8, get 2, divide by 8.
Where did you get 75 from here?
It's just a different way to do it.
Yeah, I would argue that this student would understand why the cross product property works.
And they have a good foundation in
I wouldn't have never thought of that.
Right.
Because like this is not
Yeah.
6th grade. 6th grade would be like, what just happened?
So is this a Math 7 or a Math 7A student?
I would say 7A, not Math 7. Not beginning Math 7 at least.
And I do this before, so in 7th grade I do this activity before I teach any ratios or proportions.
To see what they're.
So I do it in about November. We've done integers, fractions, and we've done like an algebra unit on like combining like terms and solving equations and inequalities, and then we do ratios and proportions. That's usually the order we move. And this is the first activity I do in our ratio proportion unit. And I just do it, it's my formative assessment of like where's our skill level at. And this is a mixture of students from an accelerated and from a typical class, but they're all totally authentic. If you guys haven't had a chance, you're welcome to trade student work to see different approaches. I think there are 3 different pages.
The only thing I give Mac is
You guys, sorry to interrupt your conversation. You guys have seen 2 different pages of student work?
Yes.
Let me see if I can, there's a third. Let me see if I can find that for you. Becky, are there extra student work pages per chance? They're all given, okay, no worries.
But we used ours already if you want to.
Oh, cool. I want to see if you guys have already seen them all.
No, this was theirs, but that's okay. You can.
They have that one, and they have,
Wherever you do on one side, you do on the other side. This kid's very good.
can I see that?
I only have 2 groups. That's why
Can I see that really fast? I'm going to bring one of these back in a second. Which one? 2 of them look too similar for me to. So here's a different one if the 3 of y'all want to look at this different one. It's kind of a compare contrast. I'll give this back to you just for future reference. You're welcome.